So hi guys, Amit and I just got off the webinar. It was pretty nice, no?
Yeah, it went fine.
Yeah, good questions. So we wanted to record a 3 minutes summary of everything that we did. So if anybody wants to get like a quick recap, you can do so. So there are some shared links on the screen right now, including lakeFS demo, the playground that we used, as well as a link for the sample repository that we used throughout this demo. Basically, we showed how to set everything up from start to finish, setting up using a Docker environment, just setting up the playground and running the repository on top of that, and then basically just running the local container that has everything we needed for the demo. That was pretty straightforward. Anything to add on that one?
Yeah, it's very straightforward. You can just run everything on this demo, lakeFS plus Airflow demo in your local environment in a Docker container.
Right. And what you'll see if you continue on listening to this playground is 2 examples that make it very easy to work with existing DAGs or new DAGs with Apache Airflow. One is basically to wrap a DAG up with lakeFS. So branching out, running the DAG, committing the changes, and merging them back in. What this gives you is an isolated environment to run the DAG into separately, and then the ability to atomically merge all the changes once the DAG completes into production. And of course, Amit, that gives you the ability to revert if there's an error, right?
Yep. Yeah. If something goes wrong in production data set, you can just revert back with a single click.
Yeah, not only for a table, but for everything before the DAG ran. And the second one, which I think is maybe even more interesting, is the ability to, within the DAG, branch, merge, commit. So this really gives you the ability to click on a failing step in a DAG and get the complete data set as it was during or just before the failed DAG, which is super powerful and I think makes life much, much easier.
Yeah, and we provide the operators to create like Airflow operators to create these branches, commit the changes into particular branch, merge the branch. So all those operators are out of the box provided by us.
Awesome. So if you guys want to see all the details, please stay tuned to see the webinar from start to finish. Otherwise, again, join us at Slack, run the playground, try out lakeFS Cloud, anything that you want to get started. Thank you, everybody, and enjoy the webinar.
Thank you.
I'm Amit with, I'm Ido with lakeFS. With me is Amit. Hi, Amit.
Hey, how are you guys?
Just a few technical comments. Everybody on this line is anonymous. If you ask a question, which you can ask on using the Q&A widget, then you can ask it anonymously or you can ask it with your name. It's up to you. We'll have a few polls throughout this section, which you can answer as well, should you want to. I run customer success here at lakeFS, and Amit runs our solution architecture. And we're here today to talk about troubleshooting and reproducing data with Apache Airflow. This will be a hands-on webinar. We're going to go through a couple of very interesting demos. But before we start, maybe just to kind of talk about why we think it's important to help troubleshoot production issues with Airflow. This all started with the idea of let's create ETL jobs, which do, you guys all know, extract, transform, and load. And with incredible solutions such as Airflow, which we love, then people were able to do a lot more in their ETL. So you can orchestrate, you can manage multiple long-running batch systems, and you basically start seeing things like what you see here on the screen, as opposed to a three steps DAG that runs on your environment. And this is phenomenal because you can achieve more with your data than you could ever achieve before due to these solutions. But the tricky part is that now that we have very complicated environments, let's say something breaks in step 50 out of 500, now what do you do? So Amit, not to embarrass you, but you've been doing this data engineering stuff for a couple of decades. So I guess I'll ask you this question. Something broke. Now what?
Yeah, normally if something goes wrong with any your ETL job, you try to look for the log and hope that things are getting logged in your log file, and then try to find the issue, what happened. Is it a data issue? It's a program issue. And then you start looking at reviewing all the data in the DAG, and also check the DAG, whether the DAG programs are fine or not, and then try to troubleshoot. And the challenge happens is, like, because data is evolving from one step, one task to another task within the DAG, then it becomes very challenging to troubleshoot. Then you try to fix the things and try to rerun your job in production and hope that everything will go fine and things will work out.
Yeah, and this becomes even more complicated, because what happens is that if it fails in the middle, now you need to figure out, what do I undo? What do I redo? Where do I start from the beginning? It doesn't sound like a lot of fun managing this. And we speak with a lot of users that absolutely, that run absolutely incredible DAGs that are highly complicated, but this is a real challenge troubleshooting this. And that's where lakeFS comes into the picture. And we're going to see this in action, but just for whoever is not familiar with lakeFS, the idea of lakeFS is basically to manage your data the same way that you manage code. It's a system that you can spin up within 20 minutes or less within your environment. So it's super straight, easy to install and run it. It sits on top of the object store itself. So S3 or Google Cloud or Azure Blob or Min.io, and basically provides Git capabilities for the object storage. So merge, branch, revert, commit, all through an API. So the ecosystem of tools that we have running in our environment, Airflow being one of them, can either access the object store regularly, or you can access the data through lakeFS and get versioning of the data. And to make it a very easy and straightforward integration, the only difference is that if before we were accessing a collection on a bucket, now we basically just include a name of a branch or a commit identifier. So I want to look at main, or I want to look at test, or spoiler alert, I want to look at the commit of step 5 in my DAG to see what the data looked at that point. And then the manipulation of the Git actions can happen in the API that I mentioned before, or we have a web user interface, or we can also do this through a command line. So here you can see, for example, the lakectl command, where I create a branch out of main, and I'm calling it testing Spark 3, for example. So that's lakeFS very, very quickly. And now we're going to walk you through a demo. Amit, do you want to kind of cover in a high level what we're going to do in the demo?
Yeah, so we'll do a quick demo setup. It will take a couple of minutes only to set up the environment. So this requires Docker on your laptop. If you want to run this demo on your laptop, Docker running on your local environment, and then sign up for the lakeFS playground. So you require a lakeFS server environment. The playground is one-click, like on-demand setup for lakeFS. So you go there and sign up for the playground. You receive the access keys via email, and it will take about 15 seconds to receive that credentials. So that's the requirement to have the lakeFS. So there are only just 2 prerequisites. One is Docker container, Docker running in your laptop, and then set up the lakeFS playground in our cloud environment. If you already have lakeFS running somewhere, you can use that also for this testing. And then also you need the demo, our demo Git repository, which you can clone. I'll go into more detail on that. And then we'll run through the demo. So that's what we are going to do in the setup today.
That's cool. So I think what you'll see is within a few minutes, you're going to have a lakeFS environment up and running. You can do that at the demo with demo.lakefs.io if you haven't done that so far. And then the cool things about this repository is that it will really set up everything from start to finish. So it's a really great way to get familiar with lakeFS. And just to give a little bit of more light, we're going to a little bit of more light into this. We're going to do actually 3 things for 2 different use cases. So first, we're going to do the setup, what Amit just covered, right? So we're going to collect, we're going to use the notebook to connect to the lakeFS server and use the Python API client, and we're going to create a repository. So kind of step 0 with lakeFS. I'm just getting started. So that's going to show you how you can benefit from lakeFS versioning really, really quickly within minutes. And then we're going to do 2 very cool things. We're going to take an existing DAG and we're going to run it in isolation. We'll branch out, run the DAG, and merge it back into main. And that kind of use case gives you a few very valuable things. It means that all the changes that the DAG did will atomically be promoted to production. So there's no, like, if a DAG fails in the middle, there's absolutely no negative outcome on your production environment. More than that, if it actually gave wrong data, then you can go to the exact commit point before you actually ran the DAG. So that's the first thing. The amazing thing about this is that it's super easy to take an existing DAG and wrap it with a different DAG that branches, commits, and merge. So we'll see how you can implement this on your Airflow DAGs today. The second thing that we're going to show is how to execute Git actions within a DAG. So inside the DAG, we'll branch, we'll commit, we'll merge, and that's pretty incredible, because what that means is that in the case of an error, when that's step 50 out of 500 errors, we can go into the logs and see the exact state of the data as it was there. So these are the quick and easy ways to start getting value and then increasing the value as you use lakeFS more and more. Amit, do you have anything to add here?
No, I think let's get started with the demo. We have a lot to cover today, a lot to show. So let me share my screen. And so I'll start. Let me hide my Zoom controls here. 1 second, and then get started. So as I mentioned earlier, you just need a Docker. So I have a Docker running on my laptop. And then you need access to the playground. You can sign up for that. It will take 15 seconds. Right now, I already have signed up. So I have another environment, lakeFS environment running. Once you log in, you'll see repositories here. I have a couple of repositories already there. So those are the 2 requirements, prerequisite. And now let's look into this demo Git repository. So let's go to this. We'll send you this link. So once you click on that link, it will take you to this samples, lakeFS samples repo. Within that, there's a sample where we have multiple notebooks, including Airflow demo, which we'll cover today. To set up, to install this container in your local laptop. So everything is bundled in a single container. So we have a demo environment, we have Airflow, Spark, everything is contained in this single container. So you will clone this samples repo first. So I have already cloned my repo here. So I have the lakeFS samples repo already cloned. After you clone that, then you will go into that folder to run the container. So once I'm there, just copy this command. This will build and run the container. So in my case, it took only a few seconds because I have already downloaded all the images. But when you run in your environment, it might take 10, 15 minutes, depending upon your internet bandwidth. So once you have the container running, if I go into my Docker desktop, I can see that this is the container name. It's a single container, everything contained within that, like all the Airflow stuff, demo stuff required is there in the single container. Once you have the container running, then you go to the Jupyter. Jupyter notebook is also embedded with this container. So click on this IP address. It's a local host basically. And then you go into your Jupyter notebook UI. So as I mentioned earlier, this demo includes multiple notebooks. We have Spark demo, Delta Lake, but today we are going to focus on Airflow demo. So there are two notebooks here, as Ido mentioned earlier, like how to convert existing DAG into integrate with lakeFS. So that's we'll cover in the existing DAG. And the second one is like if you add a lot of Git actions in all the steps within the DAG. So I'll cover both today. So let's start with the existing DAG first. Anything else you want to add, Ido, before I start?
So no, so we set up a lakeFS server, which you can do with lakeFS Cloud or with the Playground or just install. And there is a couple of links here which we're going to cover. And then we download these notebooks and we can get starting in setting up lakeFS, correct?
Yep. So we are ready to do. So now my container is running, my lakeFS environment is running, which is here. And now my notebook to start with the demo. So one thing we need here is the credentials to connect to lakeFS. So when you go here, once you get your credentials, when you sign up for the Playground, or if you already have lakeFS running, just enter your access key, secret key, and the endpoint to your lakeFS environment. So in this case, let me enter those. So I have already have all this information here, so it will take less time to copy. So I entered my credentials. And then right now I have two repositories here in lakeFS, but I'm going to create a new repo for this existing DAG. Let me call this Amit-existing DAG repo. So you can rename this repo name, whatever you want to call it. So in this case, I'm just calling it Amit-existing DAG repo. And then we have some versioning information here. So our main branch, the production branch, is we call it main. It can be main, master, whatever you want to call it, your production branch. And then I'm going to create a new branch to run this DAG in parallel to production without even impacting the data in production. So we'll create a new branch from main production branch and run this DAG. So we are not touching any data in production. We are running everything in parallel and maintaining a version control out of that. So let's set up this versioning information. The next thing is the storage namespace. As Ido mentioned earlier, lakeFS sits on top of the object store. So you can use either AWS S3 or Google Cloud Storage or Azure Blob Storage, wherever you want to keep your data in the object store, or S3 compliant object store. It can be local also. Some people use the local object store like local NetApp or Dell kind of the storage, which is S3 compliant. So in this case, I'm running my demo, this lakeFS environment pointing to S3, to AWS S3. So that's what storage namespace I'm going to use. So I'm going to call this, let me copy this just do it quickly.
It's worth mentioning, Amit, that for those users that are planning to use the Playground, the only difference between Playground and any other lakeFS installation is in the Playground environment, the data sits on our buckets. So if you want to create a new storage namespace in the Playground, you will have to look at the existing storage namespace that was created for you and use that one.
Correct. Yeah, sorry, I forgot to mention that. Yep. So in this case of Playground, when you will see the storage namespace. So you can take that and then you use that here and add a new folder in there. So let's say something like this, where you use the existing bucket name and add that the repo name or another bucket or subdirectory within that bucket. So that's what I have here. So this is all kind of setup information. There's additional setup to kind of go through to install, start Airflow in this container. So let me look into this setup. So if you click on this setup, it will open another notebook. So here I'm setting up the lakeFS client for Python using the access control and key I provided earlier in the previous notebook. Just check the credential, make sure everything works fine. I can connect to the lakeFS and also start the Airflow. And then also, once the Airflow gets started, create some connections, like in this case, how to connect to lakeFS from Airflow. So people who are used Airflow, they know how these connections work. So in this case, I'm adding the connection to connect to lakeFS, and also some environment variable to pass to my DAG. In this case, in the previous notebook, I entered a lot of these setup information like repo name, branch name. So I'm creating those variables to pass to that DAG, my access keys, repo name, branch name, etc.
So just to make sure, we're 8 minutes into this. So now we have an environment with lakeFS and the API working, the connection, Airflow connecting. That's it. We're done with the setup and we can start doing stuff.
Yes, so all the setup activities are done. So in case you see some warnings, people who are familiar with Airflow, they are familiar with these warnings, just ignore it because I'm not using the encryption right now. So now I got all the setup done. So now we are going to create the new repository. We are going to start from scratch. So let's create this repo. So when I go back here and refresh this, my lakeFS environment, so I got this new repo here, pointing to this storage environment. So if I go here right now, this repository is all empty. There is nothing in there. So the first use case, Ido mentioned, you're going to talk about the existing DAG. You have existing DAG and you want to run that in isolation, in parallel to your production environment. So it will not change anything in your production environment until it is finished, and then you merge that into your into production once the whole DAG process is done. So for this demo, I took an existing DAG, which comes with Airflow tutorial. It's called Airflow ETL tutorial. And in this tutorial, if you have used Airflow, you'll see it has extract function, the transformation, and the loading function. So I think to keep this tutorial very simple, what Airflow has done, they have done a very good job. They just print this information here. They do the order calculations. So there are 3 orders here of these values, and the transformation is adding all those order values, just calculating the total order value, and then it prints on the screen. In real life scenario, you might dump this into a file. So let's say if you load the data, you do some transformation, and then load into your final destination target. It can be an object store like S3 or Azure Blob or somewhere else. So the only change we are going to do in this existing DAG is to talk through lakeFS. As Ido mentioned earlier, like Airflow can, or your existing tool, talk to lakeFS, which will provide you versioning capability. So here I'm getting the repo name, which is coming through as a variable, which I created earlier during the setup process. And then I'm also getting the branch information, what new branch I'm using. And then also in this case, I'm creating the total order value, dumping it into a file. So I'm uploading that into lakeFS and an object as a text file. So in your existing DAG, that's the only change you have to make, is wherever you are writing to your object store, instead of writing it directly to object store, you are writing through lakeFS by specifying the repository name, the branch name. And right now I'm using the lakeFS Python client, but you can use the lakeFS Spark client also. We have a Spark client, so we have client for different languages. So in case of Airflow, you can use Python as Spark client to write to upload the object or upload the file to lakeFS, and then we keep track of version control, everything happening with the data, any files. So you can easily look into at what time, what happened, how the data evolved over time. And also, once your DAG finishes, it will merge into the production branch. And as Ido mentioned earlier, let's say if you are doing multiple changes, if you are modifying multiple files, in that case, when you merge into production, all those files will be merged together atomically into your production branch. So that's this DAG I'm going to use, existing DAG. And then we have a wrapper DAG around that. and I will talk more about this wrapper DAG. So let's connect to Airflow. So for connecting to Airflow, you'll use the admin username and the password. Password is here. When you run this command, it will give you the password. So let's look into this wrapper DAG. So simple here, like before we trigger the DAG, existing DAG, we are creating a new branch, taking it from production or main branch. So we'll take the production data and create a new branch. But when we create a new branch, it's a zero copy operation. So we are not copying the data. So let's say in your production branch, you have terabytes or petabytes of data. When you create a new branch, we are not copying the data. We are just maintaining the pointers to those files. So it's a millisecond operation to create a new branch, even if you have petabytes of data. Once you create the branch, then we are going to run this existing DAG. So if I look into existing DAG, I think, let me pull that 1 second. And then after that, once, let me see. I think I might have to run this to trigger it, and then I'll see that the DAG. So once the DAG finishes, it's going to wait till the existing DAG finishes. Once it finishes, then it will commit the changes into existing branch. We are still not committing into production branch, main branch. We are committing into existing branch, and then we'll merge into production branch. So when we merge, again, when you merge all the changes that happen with this DAG, or the changes that DAG made, all those changes will happen atomically into production. So at one shot, everything will be available to your production users. And as this DAG is running in parallel, it's not impacting your production data or your production users. So that's the DAG I'm going to run.
So that's pretty cool, because we can actually use this system and run it against any DAG that anybody has.
That is correct. So again, the only changes you have to make is to write to lakeFS instead of writing directly to object store, and lakeFS will internally write to the object store. So I just trigger the DAG, and let's visualize this DAG. So right now it's running. So I create this branch. So if I go back to my repository here and go into the branch, now I see this branch just got created. We are dynamically adding this timestamp. So if I go back here, I can keep track. So this DAG ran at 17:26 hours. So at the same time here, so you can easily keep track of all the activities happening to a DAG within a branch. So it finished the existing DAG. So if I click on this, now I can look into the trigger DAG. Again, this DAG is a simple DAG, which I mentioned earlier. It comes with the tutorial, Airflow tutorial. It has extract, transform, and load. And in case of load, I'm just writing it to if I go here in the code, you can see the same code I mentioned earlier. I'm just writing it to uploading this file to lakeFS.
That's using that Python API that you integrated within the setup. So we do that with lakeFS via code in a very straightforward way.
Yeah, that is correct. And then once everything is done, we commit the change and merge the changes into production. So that one was covering the existing DAG, where you take the existing DAG, put the lakeFS wrapper around that. We have all this code contained in this container or in along with the notebooks. So you have that wrapper code also. So in case you want to use in your environment, you can just take the wrapper and add your existing DAG and trigger your existing DAG through this. So that's awesome. The first one. Anything else you want to add, Ido?
No, I think I think it was a really good cover. So thank you. How you can run this in isolation in milliseconds branching with zero clone copy of the data. And we spoke about the benefits of this, right? You can always revert. Nothing gets corrupted in production. If it fails midway, nothing happens. And this is a really fast way to start using lakeFS with DAGs to create that isolation, like that staging environment for the DAG that's pretty impossible to achieve otherwise.
Yep. So let's look into the next one. So now we're going to start a new DAG environment where within the DAG, if you want to add more information for tracking purpose, for troubleshooting purpose. So we are going to create a new DAG with some additional information where after each step, you are going to commit the changes, if you're running things in parallel, you can create multiple branches, and all the changes that you are doing, you commit those so you can track everything easily. As the data is changing from one step to another step, all that tracking will be maintained in lakeFS. So again, in this case, I'm just going to do initial setup here, set up my credentials, my repo, as well as my branching information. In this case, I have main production branch, but for new branch, I'm going to use Airflow demo new DAG, and also the storage information. So I'll skip all this and then run this setup task. While this thing is running, I will show you how this DAG runs, looks like. So this is kind of building a new DAG from scratch, but adding all your tasks here. So in this case, let me zoom in further. I ran this DAG earlier. So here I create my ETL branch first, then commit, get the commit for this. Then I create a loading branch. Let's say if I'm loading multiple files, I might want to keep it separate in the different branches. So you can create multiple branches to load the data files that commit that data file. And once, let's say, for example, in this case, once you commit that, you might run parallel task to do some transformation. In this case, I'm doing the task 1, 2, and 3, kind of running in parallels. And within task 2, multiple tasks running in sequential order also. So in real life scenario, you might have lots of things running in parallel and sequence. But before each parallel job, you'll create a parallel branch. And then you run your transformation task. And then you'll commit your changes. Once all the changes are done, you can check, verify that it has been committed to lakeFS or not. So all this code is available. You can check later. And then merge into your the ETL load branch. And once that everything is merged into this the data load branch, we provide some sensors also if you want to use. Like you can sense the commit when the merge is done, then you do a final merge into your production branch. And we also have sensors for looking for the file. Like once you are uploading the file, you can get the file, you can compare the file, make sure file looks good. So all these operations are provided through lakeFS operators for Airflow. So we provide those operators, so it's easy to create the branch, easy to add these steps very quickly. And I will show you in the real code here. So if I go into the code, you can see here, we have this lakeFS providers, all the operators to create the branch, merge the branch. So all this makes it very easy to create all these tasks. Like for example, here, if I look into creating a branch, it's very simple here. Just calling the Airflow lakeFS operator, you specify the task ID, specify the branch name that you want to create, and the source branch. In this case, we are taking from the main. And all this information is coming through a variable. In this case, if you're familiar with Airflow, you can create those variables and pass it to your DAG. So it's very easy to add those tasks, whether to create the branch, merge the branch. Those tasks are very quick to do.
Yeah, it's this is using this operator makes it very easy. I will say that we wrote this. By we I mean Amit. You wrote this a while ago. It's interesting to see that with this DAG that uses a file sense now. Maybe if we wrote this today, we might have used like the new feature for dataset aware scheduler, which is available in Airflow 2.4. If you guys are not familiar with it and you are using Airflow, you might want to take a look at that as well.
Yeah. So that's the kind of new DAG. So let's continue. I think all the setup process is done for the new DAG demo. So right now I'm using an existing repo for this. So if I go back to my repository and search for my repos, this new DAG repo is already there because I ran this task ahead of time. So because this takes about 5 minutes to run, so I ran everything in advance. So I already have this repo created. So if I go here, again, here you'll see these branches created automatically for each different task, which I mentioned earlier. So what I'm going to do here is there are two scenarios we are going to demonstrate. One is when everything works well. The DAG ran fine. You saw earlier, everything was green. In this case, basically using a good file. So that is the good scenario where everything passes fine. But I'm also going to run it for the failover scenario where I can show you how to troubleshoot, how to use lakeFS for troubleshooting purpose of those Airflow DAG. So in this case, what I'm going to use is, in the previous scenario, I used the good file, everything looks good, all the file data is correct and everything passes through. But I also have a bad file here where data is wrong, something is wrong with the data. So I'm going to use that file and I'm going to pass that file name to my DAG. So this file name variable will be passed to my DAG and this DAG will use this new file. So in this case, let's say, as Ido mentioned, with the Airflow latest version 2.41, where you can use data where scheduling, like as the new file comes in, the DAG will automatically invoke or automatically get started. But in this case, I'm basically using this file and triggering the DAG. So I'm not doing the data aware scheduling, but I'm kind of manually triggering this DAG. And this data file has some bad data. So now if I go and visualize this graph, it will take like a couple of minutes to run. So again, it's the same DAG which I mentioned, showed earlier. So it will go through each step and run all these tasks. So if I go back to this environment, my lakeFS repo, and I refresh, so it should create these new branches here. So make sure the timestamp is correct. Not this one. I have too many windows open. So 173654, so which is this one. So within that, if you see, I'm creating multiple branches for each different task. So first, create the branch for the ETL load process, then the branches for task 1 and 2 and 3, which are running in parallel. So the reason we are doing all this thing is so we can see how the data is evolving from one step to another step. And we can maintain the versions of those and track all those. Again, when we're creating this branch, we are not copying the full data set. Only the changes which are happening in a DAG, those are only created in those branches. Rest of the things are pointers to your production data. And again, we are not changing anything in your production branch. We just have pointer to those production files. Anything we change in these branches stays only in this branch until we merge into production. So going back here, let's check. Looks
So what happened? So we started this conversation by saying I have this complicated DAG file and then something is read, something failed. What do I do now that I have lakeFS?
So like in this case, for example, this task failed. I see it's red here. So just click on this task, go into the log file. So let me open the log in a separate window here. So one thing here we did, like if you first you have looked for exception, what error message happened. So in this case, in this particular task, I'm running a Spark code and I'm partitioning the data on a certain columns in my data file, but looks like my data file is bad and there's some partitioning column is missing. the column I'm trying to partition in that particular task, that column is missing. So one thing you can also, we add here in this log is additional information to troubleshoot. So here you can see like this DAG or this task is running on a particular branch. And I also provide the URL to go to that branch. So if you click on the URL, it will straight away take you to that branch where this task is running. In this case, the task 3, ETL task 3 failed. And it's using the new file. As I mentioned earlier, this is a bad file. This is a good file, but we are running this DAG currently on this bad file. So if I check this file and open this, you'll see that it's a very simple file. It's one record. It has only 4 columns here. While if I look into the original file, the good file, it has 5 columns. So in this case, we can see that in this file, there's 1 column is missing. So this will easily help you in the troubleshooting and take you where the problem happened. As the data moved from one DAG or one task to another, it's changing over time. So you can see the latest information available in lakeFS, and we are keeping track of all the changes happening. And then if it fails, it's not going to merge into production in this case. So it will just fail and then not merge at all to production. So it's not going to impact your production branch. Everything is running in isolation without impacting your production. And once you fix this file, let's say if you fix this bad file, then you can run this DAG and then everything goes smoothly and then it will merge into your production. Anything else you want to add?
No, this is as if I took a complete snapshot of my entire environment in every step of an ETL, that I can have a task in a DAG that I can always go back to, and it's within the context in my log file, and I never had to copy anything in order to achieve it. So that's pretty incredible.
So with that, I think I'll hand it over to you.
Yeah, great. So just a recap of what we just went over, right? We went over 2 examples. One was taking an existing DAG and just running it in isolation, very quick, very fast. You can do that. You can get value around this quickly. And then the second one is getting even more value out of lakeFS by actually executing the Git actions within the DAG. I'll share some really good links in a minute that can be helpful. And to summarize everything that we spoke about, at the end of the day, when you use lakeFS, you will get 20 to 80% more storage cost reduction, not to mention the fact that you get all these snapshots that are completely free, that if you could, you might have tried to get them today. We work incredibly more efficiently as data engineers, and we can do a lot more than what we did before. And of course, there is never ever a production outage again, because I can always revert back to where I was before. lakeFS is open source. Everybody is welcome to use it for free. I'll speak about our community in a second. We also provide enterprise support to some of our customers. We provide a lakeFS cloud, which is a hosted lakeFS solution. These solutions are typically around a few $1,000s a month. So these are not enormously expensive solutions in the world of data engineering. And if anybody's interested, they can feel free to join us. Now, for a few common useful links of things that you can go do moving forward, we have our community Slack where you can join and ask any questions. Specifically, the help and getting and lakeFS for beginners channels are very helpful if someone is trying to get familiar with the solution. We spoke about the playground before. That's a way to spin up your own lakeFS environment, which is identical to lakeFS Cloud or to a local installation of lakeFS. The only difference is that the data sits on our buckets, and in real lakeFS, it sits on yours and the data stays in place. And of course, you can access the sample repository that Amit just went through this, as well as a few other ones that are pretty fun with this sample repo that's here before. Amit, anything that you want to add?
Yeah, I just saw the question on the DAG support for Snowflake or BigQuery. somebody was asking, can we write to from Airflow DAG to directly to BigQuery or Snowflake instead of writing to object store? So in most of the case I've seen in the Snowflake, people write to S3 first and then ingest from S3 to a Snowflake table. So that can be another option. Like right now, we don't directly write to Snowflake, but we are working on that to directly sync to Snowflake. But for time being, you can write to, let's say, your object store, and Snowflake will pick it up from there and just into a Snowflake. So that's the option. But we write directly to Delta tables. So if you're using Delta table, or if you're using high meta store, then that will work directly. You can write as a table directly to Delta table or high meta store tables, supported tables.
Awesome. So we still we have a couple of dozen people with us. I want to give the opportunity to ask more questions if anybody has them. So I'll just hang out here for a few seconds. Let's see if there's any questions. Additional questions. Yeah, I think this is it. So this was recorded. We'll send this over to everybody that that participated here, just so you have the reference. You have the links in front of you if you want to start it, try it by yourself. I'm Ido. With me is Amit. We're both on that Slack community if you want to reach out, and we're happy to answer questions. And again, the help and lakeFS for beginners channels will work for you as well. Thank you, everyone. And thank you, Amit. This was really awesome. A lot of fun.
Thank you, guys. Bye.
Bye-bye.